everyone, I'm Trainer Isabel and welcome back to Young Engineers. This is lesson 6 of our 10-part series where we learn about science, technology, engineering and mathematics in a cool, fun and exciting manner. Let's start by recapping what we have learned in lesson 5. In lesson 5, we have learned a new gear called idle gear. We have also learned about the speed of transmission and the velocity-gear ratio. Now, before we start today's class, let's give a round of applause to our winners of last week's lesson. Good job, guys! Now that we recap lesson 5, let's start today's class proper. In today's class, you're going to learn how to spin like a champion. Have you watched the Winter Olympics before? Have you marveled at how the ice skaters in the ice skating ring managed to do many turns? An example closer to home. Have you played with a top before? Launching it from your hand and watching it spin on the floor. A deeper question. Have you wondered how did the top remain spinning on the floor and how did the ice skater remain spinning on the ice even though there's gravitational pull? Shouldn't they topple over? Well, both ice skater and the top utilizes a scientific theory called angular momentum. The formula of angular momentum, as you can see in this slide, is the law of inertia multiplied by rotation velocity. So what then is angular momentum? Angular momentum, also known as spin, is the velocity of rotation of something around an axis. The law of conservation of angular momentum explains why a spinning top remains upright as it turns, rather than submitting to the force of gravity and toppling over. Let's watch this video to understand angular momentum a lot better.
When the skater is rotating with no net external torque acting on her, angular momentum is conserved. With her arms and leg outward, she increases her moment of inertia, which reduces her angular velocity. As she pulls her arms and leg inward, she is able to spin faster since her angular velocity increases while her moment of inertia decreases. And this is how skaters become champions.
Now that we have learned about angular momentum, let's move on to part 2 of our class. Today we're going to talk about speed increasing transmission. In lesson 5, we covered speed of transmission, speed increasing and speed decreasing. In this lesson, we're going to focus on speed increasing transmission. Now, watch this video as you observe what happens to the gear. Now, having watched the video, we're going to go through what happened in the video. In the video, you can see that there is a wheel linked to a motor and linked to a meter that is calculating how fast the wheel spins. Now, before the gears were put in, the wheel is spinning at an RPM of 402.9 RPM. As you can see, when we put a speed increasing transmission gear, the RPM jumped all the way to 2000. So now, a quick quiz. Where was the motor attached to when the gears were put into the model? Did you say the big gear? Yeah, right. The motor was attached to the 40-toothed gear. And the 40-tooth gear, being the driving gear, transmits movement into the small driven gear. And thus, having speed increasing transmission, the wheel spun a lot faster. That's because of gear ratio. Let's then recap what is gear ratio. Gear ratio or velocity gear ratio is equivalent to drive gear divided by driven gear. Now that I've recorded the formula, let's give you another quiz. On this slide, there's a list of sums for you to do. As you can see, the numbers given, underlined, are the drive gear. Could you calculate what is the gear ratio? If you have the following answers, you are right. The answer for the first one is 5, second one 4, and the last one 2. Now that we recap what is gear ratio, let's move on to our next quiz. In our next quiz, I have a request. I want you to choose 2 gears that gives me the most speed of transmission. Out of these 4 gears, which one would you choose? Do you say the 40-tooth gear and the 8-tooth gear? Very good. It's indeed both of them. Why is that so? Because using gear ratio, assuming that the drive gear is the 40-tooth gear and the driven gear is the 8-tooth gear, we have 40 divided by 8, which also gives us 5. So for every 1 rotation done by the 40-tooth gear, the 8-tooth gear rotates 5 times. Now that we have done what is speed increasing transmission, record gear ratio, and learn about angular momentum, let's move on to today's model proper. Go to Building Sheet and download Spinning Top with Launcher. Follow the steps to create your spinning top and launcher. The steps in red are enhancements. You do not need to do them if you do not have the time. Once again, before we begin, let's go through our 4 rules. Our first rule is only use the parts from your kit. Our second rule is always count. Our third rule is colors do not matter unless they are pins. Our fourth rule is always be prepared for class. Now that we have recapped all our rules, let's start building. Have you completed your model? Have you played with your model and tried it out? If you have, well done. Once again, upload a video of your models into the assessment box in Seesaw. We will be voting again for the best model for this lesson. We come to the end of lesson 6. I hope to see you next time. Bye!